Today we get to talk about prime factorization. It's one of my most favorite things to do. It's just fun. It's fun to do. So before we get started with the prime factorization, we just need to review prime versus composite numbers. So before we start, at the very top of your page, it reminds us what factors are. Factors are the numbers that you're multiplying together to get another number. Then you have your prime numbers. So prime numbers are considered factors, but they are specifically numbers that only have two factors. So sometimes a prime number can be multiplied with something else to get you a product. But a prime number specifically only has two factors that make up the number. So for example, 3. Only 1 and 3 can be multiplied together to make 3. So that's considered prime. Composite numbers are the numbers that have more than two factors. So numbers like 6. It has all of those listed out, 1, 2, 3, and 6. Because it has more than two factors, it's considered composite. Okay, but there's an exception. So 0 and 1, both of those are neither prime nor composite. They are what they are. 1 is not technically prime because it only has one factor, 1 and itself, which is 1. So that's why we can't consider it prime. Okay, so what we are going to do is we are going to color code our chart that we have here for prime and composite numbers. So it tells us that we're going to color all of the prime numbers red. I'm just going to outline them, and if you don't have two colors, that's okay. Or you can use one of the red pens in your bucket, one of our grading red pens, that's fine too. And then you can just use pencil for the others. We're not going to actually color. So if you're borrowing a red pen, don't actually try and color in all of the squares. Maybe just like outline it or just draw like lines through it. Just kind of lightly shade it, but don't try and like color it in dark because you're going to use a ton of ink. Okay, starting with, is 3 the first prime number that we have?
No.
What is?
2.
2. 2 is my first prime number. It's even. I thought all evens were all composite.
But it's the first 2.
But it's the first one. So to make 2, 1 and 2 are the only factors that make 2. So then I have 3 is also prime. 5 is also prime. 7 is prime. Oh, so it must be all odds are prime. 9 is not prime. 11 is prime. 13 is prime. 15 is not. 17 is. All I'm doing, guys, is just outlining mine so that they stand out for you. Okay, on that third row, what do you think my numbers are going to be that are prime? There's only 2.
23.
Yep.
No, 21.
Nope.
And 23. 29.
29. Very good.
70.
23 and 29. Third row, which numbers are prime?
31.
31.
31 and 39.
Mm-mm.
No.
What?
No. What's 37?
37.
38 is 34.
So think about that for a second. We know typically odd numbers are the ones that are prime, but not all odds, obviously, are prime. But 33 is not because you can divide it by 3 and also 11. 35 is not. Any number that ends in a 5 other than 5 itself can be divided by 5, so they're composite. 37 is prime. 39 is not. I can divide 39 by 3.
No, that's
Now, all other even numbers are going to be composite except for the number 2. Okay, because all even numbers can always be divided by 2. All right, moving on. 41 is prime. 43 is prime. 47 is prime. And that's it for the for this row. Okay, the next row, 53 is prime.
What about 51?
Nope.
Divisible by 3.
51.
And 59.
What about 51?
It's divisible by 3.
You can divide 51 by 3. 53 and 59 are prime. On the next row, 61 is prime. And 67 is prime. On the sevens row, 71 is prime, 73 is prime, 79 is prime. On the next one, 83 and 89. And the last row, just 97. So those are all of my prime numbers. I'm going to put a little green box around number 1 because it is neither. It's special. The rest are all considered composite.
So we can just fill in all the rest.
So the rest should be colored blue if you are color coding with me.
I kind of did the opposite. I did composite or green.
As long as you know that your prime numbers are standing out and you know which ones are prime versus composite. That is fine.
So number 1 is green.
Well, I just marked it a different color so it stands out.
I used red and blue.
Good.
I did a pencil color. Ow. Do we need our colors? Miss Watson, do we still need our colors?
Not after you're done. Okay. Does anybody, before we move on to prime factorization, does anybody need this up any longer? Or do we at least have our prime numbers marked? Because that's the important thing.
There's not a single row.
It is pretty clear so far. And these rows.
I'm going to make my prime stand out just a little bit more so that, because my blue kind of overlapped. Blue overlapped my prime a little bit.
Wait, I don't need that up because I can prime.
Now we're going to learn how to do prime factorization. So just to remind you, a prime number, again, is going to be, make sure I copy my definition the same as I did earlier, a number greater than 1 and has exactly 2 factors, 1 and itself. Prime numbers are the building blocks of all numbers, and we're going to see how in just a minute. So when I'm looking for the prime factorization of a number, it means I'm factoring that number out all the way down until all I have left are a bunch of prime numbers multiplied together. Okay, so there's 2 ways to do it. I used to call way 1, which is called the ladder diagram. I used to call that the upside down cake because it looks like an upside down wedding cake. Or upside down division because that little bar that's right here, that means divide. After we finish doing a prime factorization of a number 2 different ways, you're probably going to have a favorite way or a way that you prefer, and that's fine. You can do it that way every time. It doesn't have to be a factor tree, like a tree diagram, and it doesn't have to be a ladder diagram. You can do whichever one you prefer. Okay, starting with the first one, I'm going to zoom in a little bit now so that we can see our ladder diagram. So I want to factor 600. So that means I'm going to put 600 inside my upside down division box. And 600 is an even number, so I'm going to divide it by 2. When I do that, I'm left with 300. Well, that's still even, so I'm going to divide it by 2 again, which is 150. Divide that by 2 again, I have 75. This time I can't divide by 2, but what could I divide by? 3 or 5. So if I did 5, I would be left with,
75.
what's 75
15.
divided by 5?
15.
15. What could I divide 15 by? 3. And then what am I left with? 5. Now notice all of these outside numbers are all what kind of numbers? They are all prime numbers. And this one reminds, so I used to, whenever I taught this, used to say it looks like a hockey stick. So whenever you're identifying all of your prime numbers, you're looking at all of the ones on the outside of the upside down cake. Each one of these is a prime number. So when I go to piece it all together, I have 2 times 2 times 2 times 5 times 3 times 5. So if I multiplied all of those together, I'd end up with 600. That is your prime factorization. But what does that look like in exponential format? We talked about exponents yesterday. So how many 2's do I have?
3.
I have 3 2's. So that is going to be 2 to the 3rd power. How many, I'm going to draw a little arrow so y'all know where I got that from. I have 2 5's, but I'm going to show you something because I want you to get in the habit of writing it in the correct order. Okay, these numbers here are all considered my base numbers when I go to write them in exponential format. So I want to make sure my base numbers are in numerical order. So I'm going to go with 3 next, but there's only one 3. Do I need to put 3 to the 1st power, or can I just write times 3? Just times 3. And then how many 5's do I have? 2. So that's going to be 5 squared. That is prime factorization using the ladder diagram. Okay, well, we also have the, yes?
On the ladder diagram, for the 15 part, can you do divided by 5?
And then you would still have 5 and 3 on the outside. And good, like to that point, some of y'all were saying I could divide 75 by, what'd y'all tell me? 3? And that would be 25. And then I would divide 25 by 5, and I would have 5 here. So I'm still going to have the same numbers out. It just depends on how you divide, what you think of. But you're still going to you're going to break it down to the same prime numbers. Okay? So let's look at this tree diagram. Let's do the 600 again. And we'll kind of stick with the same numbers. So I have 2 and 300. What if this time, instead of 2 and 150, I did 3 and 100? Could I do that?
Yes.
I could. I could do 3 and 100. And then I got to break down 100. Maybe 2 times 50 makes 100. Or you could do 4 times 25. But if I did 4 times 25, I would have to have another branch coming off of here to break down the 4. Okay. Okay, let's keep going. How can I break down 50? I could do 2 and 25. I could also do 5 and 10. And then 25 breaks down 5 and 5. So with the tree diagram, you have to then go back and circle all of your prime numbers. You have to find where all of your prime numbers are. So all of the ones that don't have branches coming out from them anymore, those are considered your prime numbers. Does it match what I had before?
No.
Yeah, I still have 3 2's. I still have 1 3. And I still have 2 5's that I'm multiplying together. So my prime factorization of 600 is still going to look just like this no matter how I solve it. Yes?
It's also a hockey stick.
Yeah. So it also, because of the way that we put our prime numbers in there, it forms a hockey stick too, but it doesn't always. So we're going to do a factor tree for some of these other ones down below. But what we're going to do first is I'm going to have 2 groups work on one, and then we're going to compare. So the teal group and the checkered group, if y'all sit at those 2 tables, you're not going anywhere. You're just going to stay right where you are, but y'all are going to fill in this one here for 32. Okay, so y'all are going to work on those. Then you can compare with your group mates. Yellow and blue tables, y'all are going to work on 132. And then the peach and the purple table, y'all are going to factor out 144. And then we'll compare our answers in just a few minutes. So my teal and checker tables. Teal and checker. We are starting. Did y'all get 2 to the 5th power?
Yes.
Okay, so when you break it all down, you end up right here. I have 32 divided by 2, which is 16, divided by 2, which is 8, divided by 2, which is 4, divided by 2, which is 2. Once I break it down and I have no more composite numbers to break down any further, I know I'm done, and I'm going to put it in exponential format. Okay, so I'm going to take all of my 2 times 2 times 2, and I'm going to write it with an exponent, so it is 2 to the 5th power. Okay, yellow and blue, walk me through the next one. 132 divided by what? 2 is what? 66 divided by 2? 33. And then divide it by 3, which is 11. So what is my exponential form? It's going to be 2 squared times 3 times 11. Okay, we okay on that one? Okay, and then 144, my purple and my teal, or my peach table, 144 divided by
2.
is
72.
divided by
2.
which is
36.
divided by
3.
we can do 2 or 3, but if I did 2, it's going to be 18 divided by 2, which is 9 divided by
3.
which is 3. So my final answer is going to be 2. Very good. 2 to the 4th power times 3 to the 2nd power, or 2 to the 4th power times 3 squared. Okay, let's do one more with a factor tree. Let's do this one. So let's do 86. And I'm going to do a factor tree. Just off to the side anywhere, above, below, anywhere where you have a little bit of space. We're going to do a factor tree. Okay, I'm drawing 2 branches. So what 2 numbers can I multiply together to get 86? 2 times 43. Can I break it down any further?
Yes. Wait. No.
No.
Look at your prime and composite chart.
21.
Yeah.
Are 2 and 43 both prime numbers?
No. 40. Yes, they are. Yes.
So then I'm done.
Prime.
So my answer is just 2 times 43 is my prime factorization.
This is what we're doing, or do we have a
Okay.
worksheet?